So what we're looking at today on this lesson for our notes is, what do Harvard students on graduation day say is the cause for seasons? Now, Harvard students are smart, but even smart people can have misconceptions, can misunderstand something. And you'll see that these people misunderstand on their graduation day Harvard an 8th grade question of what causes seasons? What causes seasons? So let's take a look at this real fast and see what they say.
Karen Lee Fingerman, candidate in art.
Despite a lifetime of the very best education, students in our classrooms are failing to learn science. Many of these students will graduate from college with the same scientific misconceptions that they had on entering grade school. To test how a lifetime of education affects our understanding of science, we asked these recent graduates some simple questions in astronomy. Consider, for example, that the causes of the seasons is a topic taught in every standard curriculum.
Okay, I think the seasons happen because as the Earth travels around the sun, it gets nearer to the sun, which produces warmer weather, and gets farther away, which produces colder weather, and hence the seasons.
How hot it is or how cold it is at any given time of the year has to do with the closeness of the Earth to the sun during the seasonal periods.
The Earth goes around the sun, and it gets hotter when we get closer to the sun, and it gets colder when we get farther away from the sun.
These graduates, like many of us, think of the Earth's orbit as a highly exaggerated ellipse. Even though the Earth's orbit is very nearly circular, with distance producing virtually no effect on the seasons, we carry with us the strong, incorrect belief that changing distance is responsible for the seasons.
All right, so they said seasons are when the Earth is closer to the sun, it's summer. And they said when the Earth is farther from the sun, it's winter. Oh no, this is actually not what it is. In fact, I'm going to do this right here. I'm going to put a circle around this, and I'm going to put this right here, and I'm going to say W-R-O-N-G. No, it's not distance related. Darn it. That's even what I thought at one point in my life, until somebody corrected me and said, actually, no, Mr. Jensen, it's not that. And if we look at our textbook does a good job at showing us what it is. So if I go into our textbook here together with you, let's see what the textbook says right here. We're going to flip right on over to seasons on Earth. Most places outside the tropics and polar regions are here. Tropics are pretty much right here in the center. But most places outside of the tropics and the polar regions have 4 distinct seasons. You know them as winter, spring, summer, and fall, or autumn, we sometimes call it. But there are great differences in temperature from place to place. For instance, it is generally warmer near the equator than near the poles. Why is that so? How sunlight hits Earth. Figure 4. Oh yeah, they're showing us up here. Sunlight striking the Earth's surface in figure 4. Near the equator, sunlight strikes Earth's surface more directly, straight on, direct hit, and is less spread out than near the poles. Oh, okay, so it's spread out up there. Figure 4 shows how sunlight strikes Earth's surface. Notice that sunlight hits Earth's surface most directly near the equator. Near the poles, sunlight arrives at a steep angle. As a result, it's spread out over a greater area. That is why it is warmer near the equator than near the poles. All right. So we get more directly hit energy here, warms us up. A little bit more than here. It starts to spread it out around the curvature of the Earth. Well, let's look at this other one. If Earth's axis were straight up and down relative to its orbit, straight up and down relative to its orbit like this, if its axis were straight up and down relative to its orbit, temperatures would remain fairly constant year-round. There would be no seasons. Earth has seasons because its axis is tilted as it revolves around the sun. Anytime you see bold or darkened writing, that means that's the main thing that they're trying to get you to understand in all of these words. So here it is. Earth has seasons because, let's go back to that notes page and let's write this down, because that's our cue. Why do we have seasons? It says Earth has seasons. And I'm going to write in big letters here, bolded. Because, let's see, number one, because its axis is tilted. Because its axis is tilted. And as it revolves around the Earth, revolves around, I should have said sun. Sun, revolves around the sun. Earth has seasons because its axis is tilted as it revolves around the sun. Oh, that's why we have seasons. Yeah. Notice in figure 5, that's over here, right here. Figure 5, the Earth's axis is always tilted at an angle of 23.5 degrees from vertical. What does that mean? 23.5 degrees. If it was straight up and down like this, we'd be at 0 degrees. But instead, it's opened just slightly. And this angle right here from 0 degrees is what we call our 23.5 degree opening. That's the angle. So the Earth, as it's round, has an axis going through the center like this at 23 degrees from straight up and down. Here's the equator right there. That's what 23.5 degrees means. 23.5 degrees is our axis tilt right there. Okay, I think we're getting it. Let's read just a little bit more. I'm going to bring this down so you can see the bummer. Summer and winter. Oh, wait. As Earth revolves around the sun, the north end of its axis is tilted away from the sun for part of the year and toward the sun for part of the year. Summer and winter are caused by Earth's tilt as it revolves around the sun. The change in seasons is not caused by changes in Earth's distance from the sun. Not distance. In fact, Earth is farthest from the sun when it's summer in the northern hemisphere. Oh my gosh. They really disprove that point, don't they? Here's a picture in figure 5 right here looking at it. And what you see is you see a little red Twizzler coming out the top. That is the axis that we are spinning around. And so the Earth's axis comes right out the top and the bottom of the Earth. And it spins counterclockwise like that. And no matter what, if it's on this side of the sun, the top of the Earth is pointed more towards the sun. This is going to be our summer up here because we're going to get a lot of sunshine up here where we live when we're tilted towards. Now, when we're on the opposite side, so we go around, now we're tilted away. So we don't get the sunshine up here like we did before because we're tilted away. Always our axis is pointed towards the North Star, as we're going to see in our labs. Okay, so there we are. The axis always points the same direction as it goes down and around. The distance is always the same, even though it looks closer, it's not. Just think of a two-dimensional into a three dimensions. So there we are, right there with our understanding. Back to our notes. Right, this last part. Summer, when North Pole tilts toward the sun. Winter, when North Pole tilts away from the sun. There's our notes right there. Earth has seasons because its axis is tilted as it revolves around the sun. It's tilted 23.5 degrees. In summertime, the North Pole tilts toward the sun. In winter, the North Pole tilts away from the sun. That's why we have seasons. In fact, if the sun is in the middle, like this, here we are, two Earths. One is tilted towards, goes all the way around, and one is tilted away. This is summer for us in the north. This is now winter in the north. That's why. And in between are our two equinoxes, like that. There it is. That's the notes for seasons.